Hi, welcome everybody. My name is Andrea Garulli and I'm one of the two instructors of the course Data and Financial Analysis, which is offered in the second year of the Laurea Magistrale in Applied Mathematics. So I'm here to explain what the course is about. So this is the web page of the course. You see that the course is a 12-credit course. It's divided in two modules of 6 credits each. The first one, data analysis, is taught by myself, and the second one, models for financial applications, is taught by Professor Antonio Vicino. The number of hours is about 100, and it is in the second semester. So what are the main objectives of the course? So we want to provide the students, first of all, with basic notions of estimation theory. So we will face the basics of how to estimate quantities from data. So we will have data available, and we will try to infer some information about other quantities that we are not able to measure. Then we will address some estimation problems which involve both data analysis and dynamical systems, so quantities that change during time according to some laws, mathematical laws. And in the second module, we will provide basic concepts and tools for understanding the structure and the behavior of financial markets and related risk analysis issues. So we will see estimation problems and data analysis problems related to a particular area, which is the one of financial markets. So in the first modules, you see a short a summary of the program here. We will start with basics of random variables. I'm sure that most of you are familiar with. And we will deal with the theory of estimation, including maximum likelihood, Gauss-Markov, Bayesian, so several estimation techniques. We will consider discrete time stochastic processes because the nature of data is typical to be acquired in a discrete time fashion. And we will introduce the notion of a stochastic dynamic systems, which is a machine that processes data in the form of stochastic processes. And we will deal with modeling, filtering, and prediction of stationary signals. And so what is called time series analysis sometime in a general fashion, while in the second model it will be more specific to the financial area. And we will deal with the problem of identification of linear systems. So getting data, we want to understand how a certain system works. I mean, it doesn't matter if it is an engine or a biological system or a economical system. By getting data, we try to write down equations describing the behavior of the system and to estimate the values of the relevant parameters that describe the behavior of the system. And you will also learn how to use software tools for doing that. So there will be also a practical part. In the second module, the one dedicated to financial applications, you will first have some advanced elements of probability theory, because there are specific distributions that are useful in this context. Then we will study statistical properties of financial time series, and in particular those that describe interest rates, fluctuations, volatility, fat tails, all these phenomena that are related to the financial area. There will be elements of portfolio analysis in which you take into account the risk and how to diversify your portfolio in order to minimize the risk. And the last part will concern time series analysis with specific model classes that are tailored to the case of financial time series. And you will be able to apply the general tools of estimation theory that you have studied in the first module to the case studies that concern financial applications. And also in this module, we will make experiences with software tools for the analysis of time series in the financial context. So the exams will include both an applied part, so you will have to do an homework and the project with real world data and to analyze them, and then there will be an oral exam in which you will have to discuss what you have done, both in the first module and in the second one. You may wonder why you may be interested in an exam like this one in an applied math program. Well, there are several reasons for that. First of all, estimation is a fundamental problem in many disciplines. So wherever you have data and you have quantities that you cannot measure, you want to infer some information about these quantities that you cannot measure based on the data that you collect. That's an estimation problem. And I mean, there are many contexts in which this thing arises, from biology to economics to I mean, engineering, of course, physics, and mathematicians are important in this case because they can bridge the gap between the technology that you use to collect data, to process them, and the objectives that you have. So not only for the theoretical part, but also for the ability to manipulate data with suitable algorithms. The second one is, if you want a more broad view of the problem, you know that you surely have heard terms like the data deluge times or the big data era. So we live in a world in which we have plenty of data. And the real problem of today is what to do with them. So if you think about in the future, especially in medicine, we will be able to have a lot of data about ourselves, about our health. And we really want to extract the relevant information from them. And similarly, this happens all the time in economy, when you want to, when you have a lot of data about both micro and macroeconomic assets, and you want to extract information and to predict the behavior of such assets in the future. And you can find example in biology and many other fields. So we have a lot of data, we have a lot of computational power. We need algorithms and techniques to manipulate data in the proper way. And finally, if you're interested in the financial aspects, in the financial applications, you have to know that applied mathematicians play a key role in finance. Today, applied mathematicians has a big market in companies that are active in the financial area. So in banks or in all the organizations that do trading of financial assets, mathematicians are very welcome for their ability of understanding the complex mathematical mechanisms that are behind the buy and sell markets, and also to come up with algorithms and techniques for doing this in an efficient and effective way. So, I mean, if you are interested in these topics, you are very welcome to choose this course in data and financial analysis as an elective course in your applied math program. If you have further curiosities, you can drop me an email to andrea.garulik@unic.it. You are very welcome. Or you can just knock at my door to the office, and I'll be glad to answer. Thank you for listening, and bye-bye.